Greetings and welcome to Lecture 8.3, Simplified Form of Radicals. Now, a simplified form of a radical holds three properties. First property is that there's no perfect square that are factors in the radicand under the square root sign, or if you are doing the cubed root, there's no perfect cube. If there's no fourth root, if you're doing fourth root, then there's no perfect fourth root, and so on. We want as little possible under the radical sign as we can have. Now, second one, there are no fractions under the radical sign, and there are no radicals in the denominator. Those are the three properties that a simplified form of a radical holds. In previous lecture, we talked about two of the properties of radicals. So if a and b represent any two non-negative numbers, then it's always true that square root a times square root b is going to equal the square root of a times b, and vice versa. Square root a over square root of b equals the square root of a over b, where b does not equal 0, and vice versa. And here's a third property. A squared times, the square root of a times the square root of a equals the square root of a squared, but that equals a. Likewise, the cube root of a times the cube root of a times the cube root of a equals the cube root of a cubed, and that also equals a. And you can continue that line of thought for fourth root, fifth root, and so on. So let's work with an example to put into simplified form. So I want to put the square root of 1/2 into simplified form. Well, number one, it's breaking the rule that there is a fraction underneath the radical symbol. Okay. So the first thing I'm going to do is break it apart where I have the square root of 1 over the square root of 2. But the square root of 1 is 1, and that leaves me with square root of 1 over square root, 1 over the square root of 2. But that breaks another rule. I have the square root in the denominator. So how do we take care of that? Well, we have a rule in mathematics that if I multiply the quantity that I have by 1, it may change the look of it, but it doesn't change the actual quantity of it. So I'm going to use that property to be able to multiply the square root of 2 by our third property, by the square root of 2, to break it out of the radical sign. But here's the thing. If I multiply the denominator by the square root of 2, I must multiply the numerator by square root of 2. So if I multiply both the top and the bottom by square root of 2, I have a square root of 2 on top and a square root of 2 times the square root of 2 for the denominator. But the square root of 2 times square root of 2 is square root of 2 squared, and that leaves me with 2. Now, yes, there's still a radical in the numerator, but that's allowable. It is where it's in the denominator that is not allowable. So this is from square root of 1/2 to its simplified form is going to be the square root of 2 over 2. Let's see a similar problem. Let's write the square root of 2/3 in simplified form. So working through the problem, first I'm going to break it apart to where I have the square root of 2 over the square root of 3. Now, because I have the square root of 3 in my denominator, I'm going to multiply both the numerator and the denominator by square root of 3. And doing so, I have the square root of 3 times the square root of 2, but that is really the square root of 2 times 3, giving me the square root of 6. Square root of 3 times square root of 3 is square root of 3 squared, but that's my third property, which leads to 3. So my simplified form of the square root of 2/3 is the square root of 6 over 3. Here's a problem that's a little bit more complex. The square root of 4x cubed y squared all over 3. Well, first it breaks the rule that there's a fraction in there. So I am going to break it apart to where the numerator is in a radical all by itself, radical sign all by itself, and the denominator likewise is all by itself. 4, the square root of 4 is 2. The square root of x cubed is x square root x, and the square root of y squared is y. So the numerator ends up being 2xy times the square root of x, all over the square root of 3. But again, I don't want to have the radical symbol in the denominator, so I'm going to multiply by the square root of 3 for both the denominator and the numerator. That gives me square root of x times the square root of 3 is the square root of 3x. The square root of 3 times square root of 3 is square root of 3 squared, and that gives me a 3 in the end. So my final answer will be 2xy square root of 3x all over 3. Let's simplify 6 plus the square root of 12 all over 4. Now, it doesn't break our rules for simplified form, except that we do have a perfect square inside with the 12 here. So that does break our rule that this is not in simplified form. So 6 plus square root of 12 all over 4 will break down into 6 plus the square root of 2 squared times 3 all over 4. But the 2 squared is a perfect square, so it can come out. So I have 6 plus 2 times the square root of 3 all over 4. There is a common factor, and the greatest common factor for the numerator is a 2. So if I factor out a 2, I get 2 times the quantity 3 plus the square root of 3 all over 4. And 2 over 4 can reduce into 1 over 2, which leads us to the final solution of 3 plus the square root of 3 all over 2. Considering the last example that we did, what I would like you to do for your class problem is to simplify each of these expressions. So the first one is -4 minus square root of 40 all over 4. The second problem is -6 plus the square root of 48 all over 2. And the third problem is x minus the square root of 108 all over 18. And I want it in simplified form. Bring it to class the next class session. Several lectures ago, I mentioned the spiral of roots. Well, here's how you build it. It's very interesting to me, being a math person. But now that we have the power of the square roots and such, let's see how it's built. I'm going to take a triangle, a right triangle, with legs of length 1, and I'm going to calculate what the hypotenuse is. So 1 squared plus 1 squared is 2. The square root of 2 is the square root of 2. So the length of the hypotenuse is the square root of 2. Here's what I do from there. My next triangle, I use the hypotenuse as one of the legs, do a 90-degree angle length of 1, and I create the hypotenuse from there to create a second triangle. Now, my lengths are the square root of 2 squared plus square root of 1, all under the square root marker. But we learned that the square root of 2 times square root of 2 is 2. So 2 plus 1 is 3. So the square root of 3 will be our length of our new hypotenuse. So let's build a third triangle. So our third triangle, again using the hypotenuse as the first leg, doing a 90-degree angle with the measure of 1, building the hypotenuse, drawing the hypotenuse. Now, my new hypotenuse length is going to be the square root of the square root of 3 squared plus 1 squared. Square root of 3 squared is 3. 1 squared is 1, so 3 plus 1 is 4. So it's the square root of 4, but the square root of 4 is a perfect square, so my length of my new hypotenuse is 2. So if I wanted to build another triangle from here, I would use my hypotenuse as my leg, come out 90 degrees for one unit, and then bring it back down. If I continue to do this, this shape becomes a very nice spiral, the spiral of roots. So I wanted to show you the shape of this spiral and how it grows. So we built it up to this third triangle, but if you continue to build, you'll see you have this very beautiful spiral, very reminiscent to a nautilus shell. So that's it for this video. So until next time, be seeing you.